Hey guys, in this section we're going to be talking about polar equations in graphs. All right, so as we jump in, just like when we learn basic terminology about angles and when we learn basic terminology about vectors, we're also going to jump into another world and we're going to jump into the polar coordinate system. So before we get there, we need to discuss some terminology first. So in the polar coordinate system, okay, a point is called a pole. An array called the polar axis is usually drawn in the direction of the positive x-axis, okay? So instead of points, we have poles, and instead of our x and y-axis, we now have our polar axis, okay? So in this system, you are given an ordered pair, and instead of it being an x-y coordinate pair, like we're used to, you're given a polar ordered pair, and the first coordinate is your r, and your second point is your theta, okay? And that gives your polar coordinates. So polar coordinates are always in the form r comma theta, okay? And it's important to note that depending on what your r is, if r is positive or if r is greater than 0, then point P lies on the terminal side of theta. And if r is negative or if r is less than 0, then point P lies on the ray pointing in the opposite direction of the terminal side of theta, a distance from r, the absolute value of it, from the origin. Okay, so I know that doesn't make a lot of sense right now. Just bear with me till we get to some examples. Okay. All right, so one of the important things you're going to need to know how to do is convert rectangular coordinates to polar coordinates and so on and so forth. So if a point has rectangular coordinates x and y and polar coordinates are theta, then these coordinates are related as follows. So in your rectangular system, r is equivalent to r times cosine theta in the polar system. Your coordinate y in the rectangular system is equivalent to r sine theta in the polar system. We also have this equation, r squared is equal to x squared plus y squared. And then we have that tangent theta equals y over x, where x does not equal 0. So those are going to be our conversion factors. They will allow us to convert our coordinates from either rectangular to polar or from polar to rectangular. So those are going to prove to be very valuable as we move on in this lesson. Okay. All right, let's look at our first example. Okay. So the example says plot each point by hand in the polar coordinate system, then determine the rectangular coordinates of each point. Okay. So let's do A first. All right. So we have polar coordinates 2, 30 degrees. So as you guys can see in this video, I have these grids here. Now these grids look very different from the grids that you guys are accustomed to. This is actually polar paper, okay? So polar paper, I kind of like it. It looks like a spider web, okay? And you can think about navigating this the same way that we would navigate on the unit circle. So remember, if we are moving on the unit circle, we typically tend to start along the positive x-axis, okay? And remember, if you are moving positively, that is equivalent to moving counterclockwise. And if you are moving negatively, it's the same thing as moving clockwise, okay? So when you are navigating in these polar coordinates, so I'm going to do the first one, which is A. And they told us our point is at 2, 30 degrees. So the way that I like to think about it, I like to think that I have this person who is standing along the positive x-axis, okay, and he's facing that way. And my theta tells me which way to rotate him. So either I'm going to rotate him counterclockwise or I'm going to rotate him clockwise, okay? Since for this particular problem, we are rotating to 30 degrees and 30 degrees is positive, I am rotating him counterclockwise from the origin. Okay? So he would be along that point. And my R tells me the distance that I need to move away from the origin, okay? So as you will see these rings of this circle, those are, you consider them as the steps or how far away you're moving. So my person, this is the first ring, okay? And this would be the second ring, all right? So if I erase this, okay, I started at the positive x-axis, which was here, okay? I rotated to 30 degrees. So along this pole, okay, I'm taking 2 steps out. So that would be here. All right, so that's where my point would be. All right, let's take a look at the second one. All right, for the second one, my point is -4 2 pi over 3, okay? Now my polar paper is in degrees. They do have polar paper that's in radians. I just happened to pull some that was in degrees. So I need to convert 2 pi over 3 to degrees. And we know that 2 pi over 3 is equivalent to 120 degrees. So once again, if I start out at the positive x-axis, my person is going to rotate. I'm going 120 degrees, so that's positive. So I'm going to move counterclockwise. So it would be like my person rotated here to 120 degrees. Okay. And then my R tells me how many steps I'm going to take out from the origin. Now, it's important to note, if R is negative, okay, as in this case, I am going to walk backwards on this ray. Okay, so if you guys look at the first one that we did, okay, when I had 2 and 30 degrees, okay, I rotated to 30 degrees, but because R was positive, I walked along the ray where my angle was. Now, in this situation for the second one, because R is negative, I am not going to walk forward on this ray. I'm going to walk backwards in the opposite direction. So this ray would extend this way, okay, if I'm walking backwards, and I'm going to take 4 steps on that ray. So 1, 2, 3, 4 is where that point would be, okay? So if R is positive, you walk forward on that terminal side. If R is negative, you walk backwards, okay? So that's one way that I think about it. So if R is greater than 0, you walk forward. If R is negative, you walk backwards. Okay, so keep that in mind. All right, let's look at the third one. All right, so for the third one, we are graphing 5 negative pi over 4. Let me choose a different color. So we have 5 negative pi over 4. Okay, so remember we are assuming that we always start on the positive x-axis. And this time my theta is negative. So instead of moving counterclockwise, I'm going to move clockwise. And since my polar paper is in degrees, negative pi over 4 is equivalent to negative 45 degrees, which would be the same thing as 315. So that's about here on my polar paper. And then my R is 5. So my R is positive. So that means I'm going to walk forward on this ray that would be drawn. So this ray that would be drawn, split this about, and I would walk 5 steps forward. So 1, 2, 3, 4, 5 would be where this point is. Okay. All right, so the easiest way to do this is to always rotate your angle first and determine if you're rotating positively or negatively, okay? And then figure out your R. So remember, if R is positive, you walk forward. If R is negative, you walk backwards, okay? Now, we've determined where each one of those points are. And the second part of the problem wanted to know, okay, well, once you do that, once you plot them, what are the rectangular coordinates for each one of those points? Okay, so let's do that over here. Slide over. All right, so let me do A first. So A was 230 degrees. Okay, now don't forget we have these conversion factors up here, remember? So if we want to find out what our x coordinate would be from polar, it's the equivalent of r times cosine theta. Okay, so let me write these. So x is equal to r cosine theta, and y is equal to r sine theta. Okay. Well, now that I have this polar coordinate, the first coordinate is always your r, and the second one is your theta. So if I want to find my rectangular coordinates for this one, x would be equal to 2 times the cosine of 30 degrees, and y would be equal to 2 sine of 30 degrees. And we know that the cosine of 30 is square root of 3 over 2 times 2. The 2's would cancel, which would leave me with the square root of 3. And we know that the sine of 30 degrees is a half. When we multiply, the 2's would cancel, which would leave me with 1. So my equivalent rectangular coordinates for this problem would be the square root of 3, 1. Okay. Now, the cool thing about rectangular coordinates and polar coordinates is that they would get you to the same exact point. Okay, so it's kind of like if you're speaking two languages, I can say hi in English or I can say hola in Spanish, and they mean the equivalent. So rectangular coordinates and polar coordinates should bring you back to the same point. So if you were to plot the square root of 3, 1, they should bring you back to the same exact point. Okay, so that's one way that you can check yourself.